endocrine organ. How we hold this pancreas? We call retroperitoneum. I mean, you hold very tight, not up and down, to the back side of the body. And I was going to show this structure. Okay? This is a pancreas. We remove the stomach. Stomach actually covered on the top. And we don't show you the back side. Back side is connective tissue hold it to the body side. And you can see they had two major pancreas duct. The major one is called pancreatic duct. Go down to here. Then the second one is accessory pancreatic duct, independent open here. So all the enzyme or buffer from stomach only had two exits. Okay, one is this one together with a common bile duct joined together. Okay, and we call it duodenal papilla because it enlarged. And the other one is go to the accessory pancreatic duct. All right, and it had a lot of lobule. Let's take a look at this one. It's 99% is exocrine. We call it pancreatic adenine. It's a simple cuboid square shape at the stem cell. Produce the juice, the pH value is 7.5 to 8.8 is alkaline. So it compared to the stomach about 2. Okay, so it's much alkaline. They had two ducts. Pancreatic duct about 90%. Accessory pancreatic duct about 10%. Okay. Endocrine organ we mentioned it very well. Located in the islets. Islets are Langerhans. We do have alpha cell, beta cell. We have delta cell. We have F cell, right? Okay. And then we have enzyme to digest different type of the nutrient. Very important to highlight the color, pancreatic lipase. That's a final step to digest lipid. Break down the lipid final to simple fatty acid. The other one is nucleus. Break down DNA and RNA. Okay, and no any other organ can produce this pancreatic lipase or nucleus. Okay, and it also can digest some polysaccharide or starch we call pancreatic alpha amylase related to the sugar, but not complete breakdown to simple sugar. It also can break down the protein, but break down to polypeptide, simple short, not a simple amino acid. Okay, so pancreas is very special for lipase. Now here I want to show you here as in the small intestine here, because pancreas belongs to accessory. We have pancreatic lipase here for lipid. We also have pancreatic alpha amylase for sugar, for carbohydrate. Okay. This one didn't show detail. We also had enzyme from pancreas. So pancreas can have all enzyme digest all nutrients. And when we amplify it, it looks like this adenine cell. Its center part is actually a tube, and it's a pancreatic duct, and go to the major pancreatic duct. Isolate the island is endocrine cell, and this one looks like this one. Okay, and that is islets, and the other part they are all adenine cell. Okay, here I put some kind of indicator tell you for lipid, the lipase, you only have two from the tongue, lingual lipase, and second one, pancreatic lipase. So in the multiple choice question, if I ask you, okay, the lipase is produced from where? Okay, your answer will be the tongue and the pancreas. If I ask you, small intestine can produce any kind of lipase, digest lipid, answer is no, 0. Okay, and also the nucleus from pancreas digests DMA or RNA. Okay, and for the carbohydrate or simple sugar is from small intestine, brush border enzyme, On the single amino acid or trypsin is also amino acid, is by brush border enzyme. Okay, so for small intestine, you just need to know for amino acid, for simple sugar or glucose, is by small intestine. Okay. And for the sugar, like saliva gland, the cerebral amylase is partially breakdown. Pancreatic alpha amylase partially breakdown. Okay. Pancreas for amino acid also is kind of partial breakdown. Now we go to the liver, fixed very tight to diaphragm by falciform ligament, and the branch we call coronary ligament. And the scar tissue from the fetal umbilical vein go to the middle of the liver, become round ligament. They had a lot of this, two major right and left lobe, but also small one is caudate and quadrate. Let's take a look at stomach, liver. Liver holding very tight to that falciform ligament. Connect to stomach by lesser momentum. Okay, and here's the right and left. And if we take a look up here, this falciform ligament go to the middle, also go to the branch here. And just below it, round ligament actually is a doctor's venosus. Okay, doctor's venosus could be definitely professional. Okay, I will put it the fetus model. Definitely will ask this: what is the red colored artery, the vein actually. Fresh oxygen go to the middle of the liver, and that's gallbladder. Don't worry about this one, it's just kind of funny thing. I just want to show you the facet one. And they put coronary ligament. They all relate to falciform ligament. Okay, now someone just asked me the question today. Okay. The liver model, very important for that medical. I will ask you 4 possibilities. Okay, one is the central, the blue part here. What's this? Inferior vena cava from lower. And what's on the top? Okay, hepatic vein. You have the right side and the left side. Okay, and we send in the nutrient is hepatic portal vein. Okay, and send in the fresh oxygen is hepatic artery proper, and this one would would be common bile duct, and that's gallbladder. Okay, and usually we had right lobe, left lobe. We have small one here, caudate and quadrate here. This is very too small part. This one shows the same thing. Okay, porta hepatis. That means that is the 3 place, 3 tubes coming in and out. The body portal vein, the body artery portal, and come about that. Yeah, and it looks like cover on the surface of the liver we all call coronary ligament. It's the branch of falciform. And you also see a model had a hexagon structure. And what it means, okay, every corner had branch of hepatic portal vein, hepatic artery portal, and bile duct. They have sinusoid, that's capillary, and the cell called hepatocyte. And center part here is central vein. Central vein will go to hepatic vein. Look under the microscope, central vein. And sometimes a little bit in the corner is also central vein. And every 6 corners here, hepatic portal vein. Okay. Sometimes you cannot see very well the artery. Yeah, 6 corners, okay? Every part, hepatic portal vein, the blue one, hepatic artery portal. Okay, so the blood circulation is for nutrient is sending from hepatic portal vein, from oxygen from hepatic artery portal and go to the capillary sinusoid, central vein, central become hepatic vein, inferior vena cava of the right ventricle. Function of liver, a lot of function, but most important is produce bile to help digest lipid. And also very important for metabolism, like they can deposit glucose, become glycogen, right? Deposit lipid, deposit amino acid, can remove the waste from ammonia, very toxic, to urea, less toxic. Okay, vitamin, mineral storage, like iron, okay. And for the blood production, they also have important for synthesis of plasma protein, holding all the more than 90% of plasma produced by liver, and also phagocytosis, antigen presentation. Okay, yeah, all this important function. But I will focus on bile production. Bile will contain a lot of bile salt and cholesterol and all this bilirubin. So it will be a brown color. The function is to help break down the big part of fat to the small part we call droplet. We call emulsification. Emulsification. That means from the big lipid to small pieces, and how this lipid, pancreatic lipid, can reach to the surface. Okay. And the other thing important for this one is, increase the lipid absorption. The bile salt is a recycle. We call it reabsorption, enterohepatic circulation. That means release the bile from the bile duct and then will reabsorb later on from the low part of small intestine, ileum, reabsorb 90%. Second, the first part, large intestine, they send to hepatic portal vein, which will go through this superior mesenteric vein and then go back to the liver. So they can recycle. And it look like this one. Operator concentrated and the yellow color is bile. They go to duodenum and help digest lipid and then reabsorb and send back. Now, the gallbladder and the bile system is very important. Let me show this one first. Okay. On the ventral side, on the liver, you see gallbladder. We also divide into 3 parts. Fundus, a little bit curved. Fundus on the top, the body, and the neck. And connect to a very curved duct here, we call cystic duct. Okay. And it's starting from right lobe, the left lobe, and so we call it right hepatic duct and left hepatic duct, and joined together we call common hepatic duct. Okay. And when they produce the bile, we don't release because the sphincter is very strong holding the duodenum. We cannot set it down. And so how we do it, we have this bile in the common hepatic duct is sent back up to 60 duct and make concentrate gallbladder and take out the water. And only when the fatty fluid reaches to the duodenum, CCK release, and the gallbladder contract, and then we push the bile down. And the last part here we call common bile duct because it's the junction of cystic duct and common hepatic duct. And they open together with pancreatic duct, okay, and a sphincter here. So very interesting. If we amplify this opening, the left side here is the lumen, okay, put test by here. And the hole here we call duodenum papilla enlarge. And the upper part here coming common bile duct. And the lower part here, pancreatic duct. And they will join together. And muscle control here, hepatopancreatic sphincter, or called sphincter or artery. Okay. And that's controlled by CCK. Controlled by CCK. Okay. And so if some people have bile problem, had bile stone there, and they also have pancreas problem because sometimes this hole is not open very well. The bile will go into the pancreas, or the pancreas enzyme will go up to gallbladder, and so the two organs is related. Okay, and so in the lab, I will ask you to know all these two. Okay, let me repeat again. Number one, right hepatic duct. Number two, left hepatic duct. Number three, common hepatic duct. Number four, cystic duct. Number five, common bile duct. Number six, pancreatic duct. Okay, you can know that all this is fine system. Okay, all right. It's kind of very difficult for me to draw the line here. Okay, so I basically say on the gallbladder, we do 60 duct from liver, right and left hepatic duct, common hepatic duct, and then this one these two join together become common bile duct. Okay, and this one is controlled by sphincter or artery, and every day we produce 1,000 ml, and we concentrate to 40 to 70 ml. And so gallbladder take out 95% of the water. And the release of cholecystokinin, chole means gallbladder, cysto means cystic duct, kinin means material. That will help release, contract gallbladder, release the bile, relax sphincter aortic, and then bile and pancreatic juice can go together. Okay, this one will show you CCK working on this sphincter. You're also working on the gallbladder. Now, I add this slide tell you the disease in the liver, not only for the stone, we also had hepatitis, in fact, by virus. Cirrhosis is hardened of the liver cell, usually by alcohol drinking. Okay, gallbladder stone or common bile duct stone, very common case. Here I copied from the other book. Issue gallbladder and here common bile duct, and sometimes the stone is very big. You can find in a gallbladder. Sometimes we find in a cystic duct. Sometimes we find in a common bile duct. Okay, and what happened? Why increase the chance for the gallbladder stone? Is because you don't drink too much water, and there will be a stop. And the pain will cause in the right chest, severe pain from the front to the back side. And the other problem is because you don't have enough CCK release. They have too concentrated and become stone, become crystal. And that means your bile is not regularly released. And that means in your food, you don't have too much lipid. Okay? So I would tell someone, if you are vegan, if you don't eat any kind of meat, and you don't eat a lot of fat, okay, then you have problem. Because your CCK is very low, and your bile is make more and more concentrated and gallbladder, and increase the chance for become a stone. Okay. And so what you can do is eat more fat. Okay. So I want to say, especially for the girl, okay, you don't want to eat fat. You worry about gain weight. Not true, okay. Some of the fat is good for you, okay. And then that's good for your CCK, okay. Yeah, also good for lipid tissue produce more leptin for your reproductive function, okay. Accessory for your reproductive function. So don't feel guilty when you eat something fat. French fries are okay, don't worry. Sorry. Let me finish this now. Maybe before Alright, let me finish the last part here, then I'll stop. The movement of digestive system, we just mentioned that we have peristalsis, we have segmentation mixed at the same place. Now the third one is mass movement. It's from transverse colon all the way down to anus, and it only moves once or twice a day. And we call it defecation reflex. That means send out the solid waste. And we go through the short loop reflex and the long loop reflex. And in the anus, we have two sphincters. We have internal anus sphincter, is involuntary control. It's a smooth muscle. We have external, and that's skeletal muscle. Let me show you here. Okay, if you look at the anus, then you see inside here, interesting about this circle, internal anus sphincter, and outside is external sphincter. Okay, and here they had a lot of superficial vein here. Okay? Now, when we have enough solid waste, and the inner anus sphincter will be relaxed, and the solid waste will down a little bit, but still cannot go out because we had external anus sphincter. We are controlled by our will, and that takes some time to train. Okay, so in the young children, they cannot do it. When you have this tension, we can go to the short loop to spinal cord. We have a long loop reaction goes send to the brain. Okay. So if you're going to be a parent, okay, soon, okay, or later, then you had to know the kids, they cannot control either the sphincter in the urinary bladder, chapter 26 will mention that, or the anus. Okay, it takes some time, maybe 2 or 3 years. Okay. This one shows you the opening of UMC about we mentioned about hemorrhoid, right? We mentioned about a varicose vein, the damage to the venous valve. Okay. By the way, in the exam 2, I asked you a question: what kind of blood vessel usually can find this one? Superficial. Okay, so great venous or small venous is very easy to find this. And the other one is in the anus area. Okay, this slide I showed you before. If you are a person prolonged sitting, and then you increase the chance. Okay, or pregnant people, or you smoking. Should I continue? Good. Okay. I will finish this large intestine. Okay. The key point is large intestine. It doesn't have any enzyme. No any enzyme from large intestine. So the function is just absorb water and bile salt and some vitamin. Okay. One of them is vitamin K, very important for blood clotting. The organic waste, including the color, brown color, is from the bilirubin, and they change it to these two compounds. Don't worry about it. Okay. It also produces gas we call fructose in medical term. Okay. From the vegetable or from the bean, they produce a lot of this one from material produces gas. And for the surface of large intestine, you see red. They don't have villi. Just like stomach, it goes deep. It goes deep. It has mucosa, some mucosa. Muscularis externa lost some longitudinal muscle. Majorly only can see the circular muscle. And the other special thing is see a lot of white spot, and that's goblet cell to produce mucus. And under the microscope, you see a lot of the white spot. They are goblet cell or mucus cell. Okay. And the surface is red. And the other thing I want to see is most of the fluid, the water is reabsorbed by what? Not large intestine. It's small intestine. This new addition show you every day we drink the water or any kind of fruit, roughly 2,000 ml. We produce 150 salivary glands. We add it together, and stomach produce the gastric secretion is much. And so when it reaches to the small intestine, beginning is 9,000 ml. And the end of the small intestine go to the ileum, we take out roughly 8,000 ml. And only the last part, 1,200 something, is by large intestine. Okay, and then we lost some of it. Okay, so the one key point I want to ask you, if I ask you in all the GI tract, which part of the GI tract reabsorb most of the water, your answer is small intestine, okay? Not large intestine. Large intestine, the only function, one of them is absorb water, but just small part, not much, okay? I think I stop here. Then we can a little bit small part we will finish next time. Okay. All right, I'll stop here. Thank you.